So in this video, we're going to be talking about synthetic division. In the last video, we were mentioning how we can take an expression and divide it with another expression. But with this type of situation, you can use quotient rule because the bottom only comes as one term. Notice like how all of these denominators were very simple. So everything you were dividing with was just one term. Yes, it has many pieces, like there's a 5 and an x and a y, but it only is considered one term. Whereas like the top had like many terms. There's 1, 2, 3, 3 terms on top for this problem, but just one term on the bottom. And so if you only have one term, it's really easy to use quotient rule to divide. But if you have multiple terms, then you need to think about other ways you can divide. And one of those ways is synthetic division. But synthetic division also has its restriction. But let me just explain when it's used. So synthetic division is only used when dividing by a linear expression. So if you guys don't remember, but linear expression means that the x is to the first power. So let's think about this for a moment. I've had 3 examples here to show you. And you can see right now that this expression would not work. So this one does not work because the x here is to the second power, so it makes it quadratic. So things that are linear means that the exponent needed to be to the first power. So this exponent is not to the first power, so that means that we can't use synthetic division here. Another thing is that the leading coefficient, so the number in front of your highest power, it has to always be 1. And so like this example here, the highest power here is x, and the number in front of it is a 3, and so this won't do. So the number or the leading coefficient has to be a 1. So if it's not a 1, it's not going to work here. So basically this here is the winner, the middle one, x minus 8, we can divide with using synthetic division because the x is to the first power. The number in front of this x is a 1. So in this case, it's possible to use. And I'll show you why we use it here in a bit. It will make more sense. But basically, in order to do synthetic division, there are a few rules you want to follow. So they must order the terms from highest to lowest. And this is really important. If they're not from highest to lowest power, synthetic division doesn't work properly. And also you must always find the 0 for the linear expression, and that will be use that value in your box. And I'll explain what does it mean, this box that they're talking about. So let's do an example problem here with example 2. So in example 2, the direction says, use the synthetic division to divide each of the following. Make sure to check if the terms are missing. Okay, so basically, synthetic division is great when you have to divide with something that has 2 terms and it just happens to have like an x to the first power. So this only works when you have x to the first power and the number in front of it is also, the leading coefficient is a 1. So this only works when you have like x plus a number or x minus a number. Anything else you don't want to use synthetic division, it doesn't work. And there's other ways you can divide, but we won't teach that here in Algebra 2. So let's get started here. First thing you might need to check for is that you have to list the highest power to the lowest power. And so in this case, they actually did that for us already. It's x to the third, x second, x to the first, and then the constant. And then the next thing we need to do is find the 0 of the linear expression. Okay, let's remind ourselves, what does that mean? So when they're talking about the linear expression, they're talking about this guy because this is the only one with x to the first power. So what you have to do first is take this guy here and set it equal to 0. That's what it means by finding the 0. So I'm going to take x plus 1, set it equal to 0, and then solve for x. So I would subtract over 1, and then my x has to be equal to negative 1. And there we go. That's what it means by finding the 0. And so once you found the 0, all you do is start making your box. So I'm going to make a little box here, or a little L shape. It's kind of like an incomplete box. There's many ways you do synthetic division, but this is how I was taught. And in this box, you're going to put the 0 that you found. So you found x equals -1, so -1 goes in here. The next thing you want to do is order all of your x's by lowest to highest. So you had an x to the third, you had x squared, you have x to the first, and then you have your constant. Down below, you want to put the coefficient and match them up. So like your x to the third power had a 1 in front. So there will be a 1 here. Your x to the squared had a -4 in front. Your x to the first power had a 1 in front. And then your constant is a -1. So you set that up, and then what you do is you always bring down the first term's coefficient. So I'm going to make a line here. So you bring it down first. And then you always take this number, the bottom numbers here, always multiply with the number in the box. So 1 times -1 makes it -1. And then what you do with the top and the bottom number here is you add. So -4 plus -1 makes it a -5. Okay, you see this number on the bottom? You always multiply the bottom numbers with the number in the box. So -5 times -1 make it a +5, and it goes back up again. I'm basically doing a zigzag. I'm going down, multiply, and then it goes back here, add, down, multiply, and then goes back here, down, multiply. And so I'm going to add these numbers together, and that's how I get a 6. But I need to multiply to the number in the box. So -1 times 6 is -6. And now I'm going to add these numbers together, and that makes it a -7. So now you're probably thinking, what are we going to do with these numbers here? Turns out these numbers are the coefficients for our new expression after we divided. So here's the thing you need to know. The very end here always is your remainder. Kind of like when you divide, you sometimes have a remainder. In this case, your remainder is -7. Then after that is the coefficient, and then just keep going up by your power. So this will be x to the first, this will be x to the second power. So if we think about it logically, because you divided by an x to this guy here, your highest power now should be x to the second because you've decreased the power by 1. So in this case, you have as your new expression 1x squared minus 5x plus 6, because it's a positive, and then a -7 as a remainder, but remainders, you always write it over whatever you divide. So in this case, you divided by an x plus 1, so that is your remainder. And this is my leftover expression after I divided this into this polynomial. So you're probably thinking, okay, what just happened here? A lot of things. So first off, the first thing you need to check is that when you're dividing, you need to find the 0. And so you'll take whatever you're dividing by, the linear expression, set it equal to 0, and find the x. That number goes in the box, okay? So you can make yourself a little box and put that 0 in here. So the next thing you want to do is figure out what's your highest power. It's x to the third power. So label all the x's until you reach the constant, then put the coefficients down. After that, you're always going to take the first number and pull it down, and then this bottom number always gets multiplied to the number in the box. Okay, and then that number, so 1 times -1, goes back up here to the second line, and then it repeats. So then you always add top and bottom, and that's how I got the -5, multiplied, and then got it back here, add, came down until you're finished. And then at the very end, once you get your number, the tail number here is always your remainder, and then you proceed upwards until you reach your last number here. So you always increase the power. And then write out your expression. So these are always your coefficients that will go in front of your either your variable, or maybe it's going to be the coefficient or remainder. So on to the next problem here. Let's practice this some more. So essentially, what you always try to do is take whatever you're dividing with, and you have to find the zero of it first. And so that's where you take the equation, the linear equation, set it equals 0, and solve. But you notice when you're solving, you're always adding or subtracting it over to the other side. So you switch the signs. And so this ends up being x equals +1. But a lot of students will just skip this part because they know if they set this equal to 0, they just switch the signs on their number. So if this is a -1, they will just write this as a +1 because they understand if they set this equal to 0, they had to add the number over, so that makes the sign switch. So if you want to be quick like that, you can. But if you don't feel comfortable, set it equal to 0, find x. All right, the next thing we need to do is locate what's the highest power. In this case, it's x to the 4. So I'm going to write x to the 4th and write out every single exponent until I reach the constant. So x to the 4th, 3rd, 2nd, 1st, and constant. And then I need to write down the leading or the coefficients that went with it. So in this case, there's a 1, a -3, a 2, a -4, and a +4. So I just took the coefficients in front and wrote it beneath them. From there, remember, the first digit you always bring down. And so this 1 comes down. Then you always take this number here at the bottom and multiply it with the number in the box. So 1 times -1 makes it a +1. And then when you are dealing with the numbers vertically, you always add. So you always add vertically, and this would give you -2. And you always multiply diagonally with the number in your box. So -2 times 1 makes it a -2. And then I'm going to add, and so that makes it a 0. 0 times 1 makes it a 0. And then, let's see, -4 plus 0 gives me a -4. -4 times 1 gives me a -4. And so I have another 0 when I add vertically. Okay, remember, the last digit at the end is always your remainder. And then after that, it's your constant, your x to the 1st, x 2nd, x to the 3rd. So oftentimes I go backwards. I always start at the very end and go this way. It's much easier to figure out what is being represented here. So it looks like I don't have a remainder here. So I don't have to, write this number over the denominator, which is x minus 1. I can just go ahead and write my equation. So this will end up being 1x cubed minus 2x squared. Now notice how this x to the 1st is a 0, so that means I don't have to write x to the 1st power because the number in front is 0, so it will cancel it out. So I really just have a -4 afterwards. And this is it. Now some of you guys are probably thinking, do I have to write this one that's in front of x cubed? And no. So if you understand that if you don't write this one, the coefficient by default is 1, then you don't have to write it. But some people like to take comfort in writing it. And that's perfectly fine. All right, so I hope you are starting to get into the rhythm of things, but let's practice this a couple more times before we go into the next concept here. So this one here gets a little bit tricky because it's x to the 5th power, and it looks like we have some terms missing, so we'll see how we can handle that. So again, if you're looking at this, you can either, if you're comfortable, you can say, okay, this is x minus 4, so my box number has to be a +4, because if I set this equal to 0, for those of you who are not comfortable, you can set it equal to 0, add the 4 over, and then realize, the 0 here is x equals 4. And then realize it's a +4 in here. So whichever way you do it. Now, I know that my highest power here is to the 5th, so I need to write out all my exponents until I reach the constant. And so the numbers underneath them is 1, but I don't have x to the 4th. And so if I don't have x to the 4th, I still need to write something down, but it'll just end up being 0 because I don't have it here present. So if your exponent or whatever your term is not located here, then you're going to represent it with a 0. But x to the 3rd is represented with a -4. X to the square or x to the 2nd power is also represented here with a +4. X to the 1st and the constant is not represented, so I'm going to put a 0 there. From here, I need to start bringing down my number. So the first number is dropped down. And so remember, these numbers get multiplied with the box. So diagonally, we're going to multiply. So 1 times 4, positive 4, and we always add vertically. So 0 plus 4 is 4, and then multiply diagonally. 4 times 4 is 16. Negative 4 plus 16 gives me a positive 12. 12 times 4 gives me, let's see, 48. 4 plus 48 gives me 52. Okay, these numbers are getting large. 52 times 4 gives me 208. I did that with the calculator. All right, now I'm going to take 208 down. So I have 208. And now I need to multiply this one more time with my diagonal. So 208 times 4, putting that in my calculator, gives me 832. All right, so from here, if I add 0 with 832, I just get 832. So remember, the last number here is your remainder. So I have a very large remainder here, and then it's your constant, x to the first, x second, x to the third, until you run out. So it looks like our highest power here is x to the fourth. So my equation is going to look like x to the fourth, or 1x to the fourth, plus 4x to the third, plus x to the 12 squared, plus 52x, plus 208, plus 832 over whatever I divide it, since this is my remainder. My remainder here is going to be 832 divided by x minus 4. And so this here is my final answer. Whew, that is one long answer. All right, so basically with this one here, I wanted to showcase that if you have missing terms, make sure you still write them, but just call them, label their coefficients as 0. All right, last but not least, this one here, just thought I'd throw it in there. It has y's instead of x's, but it's still the same thing. You're just going to have y's here. Okay, so from here, let's try to find the 0 to put in our box. So here's our box here, and then this is y plus 2. So I know that there's going to be a negative 2 in here. But like I said, if you're not comfortable with switching the signs yet, set it equal to 0, solve for y, or solve for the 0, and then y is going to be equal to negative 2. And there we go. It's that same number that goes right here. And now what we're going to do is label our powers. So our highest power here is x, or not x, y to the third. So we're going to decrease this until we reach the constant. And so we have everything labeled, and we're going to put the coefficients down below. So I have a 1 for y to the third, 11 for y second, and then y to the first has a negative 10 and then a positive 6. So from there, we're always going to pull down the first digit, and then we always multiply diagonally with the number in the box. So this ends up being a negative 2, and then I add vertically. So 11 plus negative 2 makes a 9. 9 times negative 2 makes a negative 18. And then if I add vertically, negative 10 plus negative 18 makes a negative 28. Negative 28 times negative 2 makes it a positive 56. If I add, then I get a 62. So it looks like I do have a remainder, because the last number is always the remainder. So I don't have a 0 here for the remainder. Constant is next, and then, oh, sorry, not x, y to the first, and then y to the second. So it looks like I have 1y squared plus 9y minus 28 plus 62 divided by y plus 2. And there we go. We have our final answer. So just using a different variable, but same skill. All right, so in the next video, we are going to apply the synthetic division method that we just learned to figure out how do we factor using it. Synthetic division is great for taking a polynomial and breaking it down into its factors. And I'll show you what I mean when we get to the next video. All right, that's it. Bye, guys.